A method to solving a system of equations could also be done through substitution. So when we use substitution is when one equation is solved for a single variable. So it would be if I had a set of equations where I maybe had a y equals, and then I had something else where it's like x plus y equals 12. What we're going to do is substitute that in. So as long as you have one equation that's just set equal to either x or y. What should my answer look like? It should always be an ordered pair, okay, in form x comma y. If you don't have an x, y, it should be alphabetical. So maybe it's like a comma b or m and then n. But if it's not x, y, make sure it is alphabetical. So let's take a look at some examples. The first one says y equals x plus 1, and then y equals negative 2x minus 2. So what I'm going to do is I'm going to say, okay, if this is what y equals, I'm going to put a box around it. And what I'm going to do is I'm going to substitute it into the other equation where the y is. So I find the y in the second equation, and that's where it is going to go. So if I'm going to rewrite my second equation, instead of y, I'm going to write what I had in my box, which is x plus 1, and then continue the rest of the equation, equals negative 2x minus 2. So now what I have is an equation with a single variable, and now I can just solve. So these parentheses don't mean much because I don't have a coefficient, so I can drop them. So I have x plus 1 equals negative 2x minus 2. So I would want to get my variables together. So I'm going to add 2x to each side. So 1x plus 2x is 3x. So I've got 3x plus 1 equals negative 2. To solve for x, I would subtract 1 from each side, leaving me with 3x equals negative 3. Divide each side by 3, so I get x equal negative 1. Now I also need the y coordinate. So I have two equations in my system up here, and I can pick either one. I'm just going to pick the first equation. So I've got y equals x, which I now know is negative 1. Plus 1, so my y value is 0. So my ordered pair is negative 1, 0. Okay, so let's try another one. Let's take a look at example B. We got y equals 5x plus 9 and y equals 5 halves x plus 33. So again, I'm going to put a square around what my equation is equal to, and then put an arrow to substitute it in to the other equation where that y equals. Okay, so you're only plugging in what the equal sign is equal to. So this time I've got 5x plus 9, substitute it in for y, so that equals 5 halves x plus 33. Again, I'm going to want to get my x's together, so I'm going to subtract 5 halves x from each side. So 5 minus 5 halves is 2.5x plus 9 equals 33. Next, I would want to subtract 9 from each side so I can get my x by itself. So I've got 2.5x to give me 24. Then divide each side by 2.5. So I'm going to get x to equal 9.6. Okay, so now I have to find my y. Again, I usually just select the first equation, but it doesn't matter. So I've got y equals 5 times x, which I now know is 9.6, plus 9. If I plug that into my calculator, I'm going to get 57. So my ordered pair is 9.6, comma 57. Okay, just make sure that you write it x and then y. Example C looks a little different because now my first one says 4m equals something and then just an m equals. So what you want to do is you want to find the equation that is just equal to a single variable. So this time I'm going to choose my second equation, which is just my m equals, and I'm going to substitute it into the top equation this time for where the m is. Okay, so you're always finding when you just have the equation equal to a single variable. So that first equation is going to say 4 times, but instead of n, I'm substituting in 6p plus 15 equals 16p plus 5. So now if I want to go ahead and solve that, I'm going to distribute over on the left side. So I've got 24p plus 60 equals 16p plus 5. Again, I would want to get my p's together, so I'm going to subtract 16p from each side. That's going to give me 8p plus 60 to equal 5. Then I'm going to subtract 60 from each side. So I'm going to get 8p to equal a negative 55. Divide each side by 8. So I'm going to get p to equal negative 6.875. Okay, again, I need to solve for my other variable. So this time I'm going to grab my second equation because it's a little bit easier to solve for m. So I'm going to have m equals 6 times p, which we know is negative 6.875, and then plus 15. If I plug that into my calculator, I'm going to get negative 26.25. Okay, now here's the first example where we don't have an x and a y. This time I've got an m and a p. So like I said, it goes alphabetical. So I'm going to have negative 26.25 first, and then comma negative 6.875. Okay, so put your ordered pairs alphabetically if it's not an x and a y. All right, let's move on to something maybe a little trickier. So now we've got a little bit of fractions. Okay, so it's still the same concept though. This first one is set equal to a. So I'm going to plug it into that second equation where the a is. So I've got 2/3 b minus 6 equals 1/4 b plus 2. So again, I would like to get my variables together. So I'll subtract 1/4 b from each side. 2/3 minus 1/4. Careful in your calculator is 5/12 b minus 6 equals 2. Then I'm going to add 6 to each side. So I'm going to get 5/12 b equals 8. And then I'm going to divide each side by 5/12. Or you can multiply by the reciprocal, whatever works better for you here. And then b is going to equal 19.2. So now I want to solve for my a. Again, it doesn't matter. I'll just choose my first equation. So I've got a equals 2/3 times 19.2 minus 6. And that's going to give me 6.8. So now when I write my final ordered pair, I've got 6.8 comma 19.2 because I'm alphabetical A and then B. Okay. Example E is getting a little trickier, but it's still keeping that same concept in mind. Okay, I have one equation that's equal to one variable. So I'm going to take this first box item, which is what x equals, and plug it into the second equation where x is. So I've got 4y squared minus 34 equals 2y squared plus 16. Again, I want to get my variables together, so I'm going to subtract 2y squared from each side. So I've got 2y squared minus 34 equals 16. Then I'm going to add 34 to each side. So now I've got 2y squared to equal 50. And here's the really important part of this example. You are going to divide first. So I get y squared to equal 25. And then I am going to square root it. So then I could get 5, or I could get a negative 5. Okay, because negative 5 squared is also a positive 25. So remember, first to divide, okay, and then you get two answers here, and that's going to be a negative 5 or a positive 5. Okay, those are important notes for you to make in your notes packet right now so that you get that correct the next time you see something like this. Okay, so if I pick either example, I'll just go ahead and grab that first one. X equals 4 times y, 5 squared, minus 34. If I go ahead and plug that in, I should get 66. Now I also need to plug in negative 5. Okay, so one ordered pair is going to give me, oops, I wrote that backwards, x and then y, so 66 comma 5. Okay, or x could equal 4 times negative 5 squared minus 34. And that's also going to give me a positive 66 because a negative 25 squared is also positive. So here you're going to have two answers. Okay, so just go ahead and be careful there. Check that on the calculator and make sure you're getting the same answers as I am. If you didn't, that means that you did this part wrong. Okay, because 5 needs to be squared first before you multiply it by 4. So you really want to do 4 times 25 there. Okay. Very good. Let's move on to something even more tricky. So now this time I've got 3 equations. So what we're going to have to do is a double substitution because we want to get all of the x's together so that we can then substitute that in for y and z. So if I look at my second equation, I know that y equals negative x. So I can plug that into the top equation where y goes. I also know that z equals x plus 1. So I can substitute that also into that top equation where z goes. So if we rewrite this first equation, I'm going to have x plus 2, but instead of y, okay, I'm going to plug in, I'm going to substitute in my red variable there, minus z, but instead of z, I'm going to substitute in what z equals, which is x plus 1. Okay, and that whole thing equals 1. So it's a double substitution so I get only x's so that I can solve my equation. So now if I go to simplify, I've got x plus 2 times negative x, which is a negative 2x. Be careful here, this is like a negative 1 that I need to distribute. So that's minus x minus 1 to equal 1. So now if I put together my like terms, x minus 2x minus x simplifies to negative 2x minus 1 equals 1. So then I'm going to add 1. So I've got negative 2x equals 2. Divide by negative 2. So x equals a negative 1. Now what I have to do, because this is a little bit more complicated, I have to plug that in twice. So now I want to know that y equals negative x, so negative negative 1, which makes that a positive 1. I also know that z equals x, negative 1, plus 1, so I now know that z is going to equal 0. Now when you write your ordered pair, it's still alphabetical, but there's going to be 3 numbers. So it's going to go x, y, z. So negative 1, 1, 0. So an ordered pair with 3 answers. Okay, so that one may look kind of confusing at first, but I think when you simplify it down, it isn't as bad as you think. So let's try a story problem. Mrs. Johnson wants to have a clown deliver helium balloons to her daughter's birthday party. 2 companies offer this service. Happy Helium charges 80 cents per balloon plus a $6 fee. Balloons and More charges 95 cents per balloon but has no delivery fee. For what order of how many balloons is the cost the same, and what is that cost? So our 2 variables would probably be our cost and then n, which would be the number of balloons. Okay, so in our system, we're going to have one equation for each store. So the first store, the cost is 80 cents per balloon. So 0.80 for 80 cents per balloon means times n. Okay, remember that's the one that gets the variable, plus a $6 delivery fee. Our second equation for the Balloons and More, our cost is going to be 95 cents per balloon. So there's your variable, that's your slope, n, but it has no delivery fee. Okay, you could write plus 0 if you want, but I'm just going to leave it. So now what we want to do is we want to solve this system. Okay, so again, I can put a box around what c equals, and I can plug it in for the c in that second equation. So I've got 0.08n plus 6 equals 0.95n. To get my variables together, I'll subtract 0.8n from each side. So I'm going to get 6 equals 0.15n. Divide that by 0.15. So n would equal 40. So the cost is going to be the same when there are 40 balloons. Okay, so 40 balloons is our answer. All right, we'll try one more. You're considering 2 job offers. I want to know which one is the best in the long term. Shady Acres offers a salary of $32,000 per year with a $1,000 pay increase per year. Whispering Pines offers $28,000 per year and a $1,500 pay increase. So how long will it take until you'll be earning the same salary at either job? Okay, so S would be our salary here, and Y would be the years that you're at that job. So kind of set up similarly to the last one. My first equation we'll talk about at Shady Acres. So my salary is going to be $32,000 plus $1,000 each year. Okay, per, again, getting your slope, getting your variable. And then at Whispering Pines, my salary is $28,000 plus $1,500 each year. Again, that's each year. And then to solve this, again, I can put a box around what that equals and substitute it in for S. So I've got 32,000 plus 1,000y to equal 28,000 plus 1,500y. Okay, so to solve, I'm going to get my variables together. So I'll subtract 1,000y. So I'll get 32,000 equals 28,000 plus 500y. I'll subtract 28,000 from each side. So that gives me 4,000 equals 500y divided by 500. So y will equal 8 years. Okay, so that is how we solve systems using substitution. Go ahead and work on your homework, and that will be that. And then just bring any questions you have to class tomorrow.